Hello, everybody. This is Aaron Schwartz, one of the secondary math specialists with Montgomery County Public Schools. In this screencast, we're going to look at an instructional approach that helps students understand the portion of the coordinate plane that they're supposed to shade when looking at linear inequalities. That's why we're calling this video Shady Dealings, or using structure to determine the included values. In Unit 2, Topic 3, students use systems of equations and inequalities to determine the combinations included in solution sets. Some of the key ideas include that inequalities are defined by parameters or constraints. Inequalities have solution sets that include many combinations of values. Solutions may exceed a constraint, fit a constraint exactly, or be within the defined constraint. The parameter or constraint represents a boundary that divides between values that exceed or are within the parameter. A lot of questions surround this particular topic. Many of them include questions about why we would start with systems of inequalities and move towards systems of equations last. But starting with linear inequalities has some distinct advantages. By using inequalities as a start, we can define large sets of solutions and then add constraints to limit the solution set. Eventually, additional constraints will narrow the solution sets to just one solution point. Some helpful skills that students have learned. Students have learned to graph and build tables for linear equations in standard form. This is developed in Algebra 1, Unit 2, Topic 2. Students work with inequalities as representations to compare amounts. This is done extensively in elementary school. Students have also learned to solve single variable inequalities. This skill is developed in Math 6, Math 7 or IM, Math 8, and in Unit 1, Topic 2 of Algebra 1. One of the first lessons of this particular unit and topic involves the scenario pet sitters. The pet sitters context is presented in the curriculum as an entry into understanding linear inequalities. Carlos and Clarita plan to invest much of the $1,280 they earned from their last business venture to purchase cat pens and dog runs. It will cost $32 for each cat pen and $80 for each dog run. When students are given this context, they are asked to determine combinations that are too big, too small, and just right. And we're going to be taking this approach through the video. We have the same scenario that we just presented. The first thing we're going to do is present this as a linear equation. We know that 32 times the number of cat pens and 80 times the number of dog runs should equal $1,280 exactly, or 32x plus 80y equals 1,280. Even though this topic focuses on linear inequalities, we're going to start with the linear equation, because this way we can start by determining values that fit the constraint exactly. We're going to create a table of values for those combinations that meet the constraint exactly, and we're going to use a similar approach that was developed in an earlier video. We're going to look at some of one and none of the other. We're going to be looking at when we have all cats and no dogs, and all dogs and no cats. We're going to start when we have no cat runs and all dog runs. When we have 0 cat pens, we'll have 16 dog runs. Now let's go to when we have all cats and no dogs. When we have no dog runs, we'll have enough money to buy 40 cat pens. From here, we can develop a slope and determine other combinations that will meet the constraint exactly. We can see that when we decrease the dog runs by 16, we can increase the number of cat pens by 40. When we reduce this ratio, we can see that we can reduce dog runs by 2 and increase cat pens by 5. This allows us to have 5 cat pens and 14 dog runs, 10 cat pens and 12 dog runs, and so on. We now have a table that represents combinations that will meet the constraint exactly. We can now graph these ordered pairs on a coordinate plane and make some observations. One of the observations that students will make very quickly is that we have a pattern that looks like a line. In this case, we've graphed these as discrete pairs. The reason that we've graphed this as discrete pairs is we wouldn't have half of a cat pen or a third of a dog run. For a later portion of this video, we will be representing this boundary line as a continuous function. Now let's look at exceeding the constraint. Notice I still have our graph visible on the screen. This is because I want to take the number of cat pens, and all I want to do is add in extra dog runs, because I know that if I was able to meet them exactly before, extra dog runs are going to cause us to exceed that constraint. So instead of 0 and 16, I might do 0 and 17. Instead of 5 and 14, 5 and 15, and so on with the values that I have listed in the table. The next thing I want students to do is graph these values. Students should notice that all of the values that they've graphed are above that line. This is a key learning that we'll come back to in a few minutes. Let's look at being within the constraint. Obviously, we want to lower the number of dog runs this time. We want the number of dog runs to be less than our values that met the constraint exactly. So I've selected a bunch of ordered pairs that represent values lower than meeting the constraint exactly. I've now graphed them, and I can notice that when we're within the constraint, we're below the line. Let's take a closer look at this. At this point, I can now say that anything that is above that line represents exceeding the constraint, and anything below the line represents being within the constraint. And all of the points in those regions represent solutions to this inequality. I can then shade to represent all of the possible points that are included in each solution set. From here, I can ask students to make observations based on the equations and the inequalities. When we were greater than the $1,280, those were the points that were above the line. When we were less than the 1,280, those were the points below the line. And when we exactly met 1,280, we were on that line. This means that when 32x plus 80y is greater than 1,280, those are the combinations that exceed the constraint. Greater than will always be where we exceed the constraint. When we have 32x plus 80y equals 1,280, that's what we call the boundary line, and that's going to be the combinations that fit exactly. When we have 32x plus 80y is less than 1,280, those will be the combinations that are within the constraint. Students can now identify the shaded regions for inequalities in the form ax plus by is greater than c, when b is greater than 0. We need to take the learning out of the context and ask students to observe what happens when b is less than 0. This will build student fluency with the topic. Additionally, students can extend the learning for lines described by y is greater than mx plus b or y is less than mx plus b. We're going to move to a Desmos activity to explore standard form equations in the form ax plus by is greater than c. I've now switched to a Desmos presentation. I have an inequality ax plus by is greater than c. But I'm going to move the value of b around on this slider. This is going to change the inequality, and we want to make some key observations. The thing that we want students to observe is that whenever b is greater than 0, we're always talking about the portion that's above that line. The moment that we're looking at values of b that are less than 0, we're always talking about shading below the line. This is really critical. This means that whenever b is negative, we're actually going to be doing the opposite of what that inequality would suggest. When it's ax plus by is greater than c, we're shading above the line. But when it's ax minus by is greater than c, we're actually going to be shading below. Students can continue this observation with various forms of linear inequalities as presented in Desmos. I hope that this video helps teachers create classrooms where students explore math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below. Thank you, and have a good day.